Learning outcomes. After studying this module, you shall be able to understand the meaning and importance of R&D strategy. Analyze the important choices in R&D strategy. Introduction. Research and development is the process for development and cultivation of new products. Manufacturing, product design and information technology companies all have an R&D strategy. These industries are driven by consumer demand for their products. New products or improvements on existing products are required to maintain the company. The best R&D strategy has a long-term view, is focused on cost containment and has a specific set of delivery items. The costs associated with research and development have a huge effect on strategy selection. In many cases, R&D is a core aspect of the business model and a specific percentage of revenue is allocated to this expense. For example, pharmaceutical companies typically spend between 20% and 35% of their annual revenue on R&D. This is absolutely essential because the development of new products and securing of patents allows the company to establish ownership of a product line and secure a long-term revenue stream. The first step in selection and R&D strategy is to govern where the business should be in 10 or 20 years. The next step is to develop a reasonable plan to attain that goal. For example, a motorcycle shop that wants to become the industry leader for making custom bikes for clients age 50 or older has a clear focus. The research and development strategy to achieve this goal must include creation of new parts, accessories, and designs that will appeal to this target market. Sound independent research is absolutely essential when creating an R&D strategy. Companies invest in professional research services, regulate the feasibility of the long-term goal, and to identify the steps necessary to reach this goal. Metrics near the size of the target consumer, group's median income level, product interest, and overall developments are important to avoid costly mistakes. Cost containment is the most important part of any R&D strategy. The methods used to manage this aspect of the business vary, but the most popular options are cost accounting and budget management. This can be a time-consuming practice, but it yields the most accurate results. Budget management is used in large companies. The lead researcher is allocated a specific amount of money in different categories such as supplies, staffing, and equipment. The project is reviewed on a regular basis to determine progress and potential viability. Expenses must be justified, and projects that are not progressing well are stopped. An effective R&D strategy allows for a combination of creative freedom and focused efforts. Most companies have a process for reviewing research ideas and proposals. The proposal must include a timeline for the production of a viable product, a cost estimate, and a target market. In many organizations, there is a committee of senior staff members who review the proposals and select those that are most likely to be successful. Some firms quietly do research and development, but other firms rely on their R&D for the survival. This chapter basically deals with the activities which are important for the survival and growth of the firms, and without these activities firms cannot retain in the market or compete with other firms. Like other strategies, production, marketing, personnel and financial, R&D strategies are also important. Research and development consists of activities through which a new product can be developed or an existing can be improved. This function may enable find new dimensions for business or reinvest or re-engineer the production process or the product. Hence, this becomes an important and integral part of production function. So, we can say that R&D employees and managers perform tasks that include transferring complex technologies, adapting processes to local markets. There are various strategies such as product development, market penetration and related diversification through a new product can be successfully developed and the old products can be significantly improved. So, with the help of R&D strategies, firms in many industries relying on the development of new products and services to fuel profitability and growth. Now, whenever planning for R&D strategy, the stages involved in technological innovation are basic research. It is the kind of work which is done in various laboratories, R&D department, and the outcome is not very clear, like Watson and Einstein applied this kind of research in their inventions. Applied research includes studies which are designed to identify the specific potential of general knowledge and provide directed knowledge. Development. It is the stage of growth or advancement of the products or processes of the firms. Pilot plant testing. Testing the economic as well as physical feasibility of the model which is used for the development of the product. It provides cost knowledge. Manufacturing, tooling and debugging. It is the designing and assembling of new manufacturing equipment and person involved with efficiency and effectiveness. Marketing startup. It deals with overcoming of any new technical problems of physical distribution. Meaning and scope of research and development strategy. Research and development strategy can be defined as the tasks of innovative plans, that is, creating and commercializing inventions, meet the responsibilities of technological plans, that is, external and internal creation and retention of technological know-how. It produces activities such as basic research, fundamental research, technology development, advanced development, concept development, new product development, process development, R&D portfolio management, technology transfer, etc., but generally not include technology licensing, innovation management, inventory planning management, corporate venturing, incubation, etc., as those are sufficiently independent activities that can be carried out without the presence of R&D function in a firm. Aspects of R&D. Policy decisions in the area of research and development involve two aspects: allocation of resources and the manner in which these activities can be undertaken. The first aspect is related to quantum of resources that may be needed for research and development, which largely depends on the type of organizational activities, the type of R&D activity to be undertaken, and the sources of technology to the organization. Another aspect in R&D is to decide how R&D activities will be carried on. One, undertake its entire R&D activities on its own, or it will collaborate with other outside research agencies. Both the alternatives have their own cost and benefit implications. Elements of research and development strategy. The key decisions or factors that are also known as elements of any research and development strategy. One needs to decide upon the basic elements before proceeding for formulating specific R&D strategy. The key issues are structure, that is where, process, how, people, who, portfolio allocation. One has decided from the options available to an organization. The sole objective of research and development strategies, like any other strategy, should be achieving success. For the attainment of this objective, there are 4 elements of research and development that includes structure, processes, people, and the portfolio. So, together, decisions made in each of these categories constitute the research and development strategy. Structure, that is where. It refers to the set of decisions with regard to both organizationally and geographically. The decisions has to be taken in respect of size and location of research and development, focus of research and development market or technology, and degree of centralization or decentralization, whether R&D units would report to business units or are autonomous, whether research is organizationally separated from development, and the degree to which R&D utilizes external resources and partnerships. There is no single best structure for an R&D organization. Suppose a highly centralized R&D organization facilitates communication and integration across different functional groups. At the same time, centralization forfeits the benefits of having a geographically diversified footprint of R&D facilities located close to different global technology hotspots. The better tactic depends on the organization's core hypothesis. Betting on accumulation, then the centralized model is better. If it thinks tapping geographically diverse knowledge bases is the key to winning, then the decentralized model is a better route. Processes, that is how. These are also formal and informal ways that carried out R&D. This category includes choices about project management systems, the governance of projects, including the nature of senior management reviews, the sequence and flow of critical project tasks, the timing of reviews, and the indicators used to track projects. Here we should consider the choice between a highly structured R&D process with tightly specified procedures, review points, etc., and a flexible process. Whether a structured or flexible process is better, this depends on broader R&D goals and other choices. An R&D organization working on highly uncertain technology may need much more process flexibility so that it can have the latitude to explore and iterate. In contrast, where R&D must be tightly coordinated with other functions like manufacturing, a more tightly specified process may be necessary to keep everyone on the same page. People, who? It is another significant component of an R&D strategy. Despite the statement that the use of sophisticated instrumentation, computer imitation, and laboratory automation are growing, R&D is still a labor-concentrated process, as we can say that the selections about human resources, such as the mix of generalists versus specialists, practical backed grounds, exercise, work styles, career paths, and layoff policies, etc., have a significant impact on R&D strategies. But there is a best human resource plan for R&D. For illustration, layoff policies and career paths. Some corporations indirectly promise their R&D workforce that they will have comparatively stable employment and seek to appeal people who will incline to stay at the company. And other corporates are relaxed with the degree of churn. They do not suppose people to stay laterally, but they promise much job security. Now, which approach is better? This will be governed by on the location of the R&D laboratories, a structural choice. If any company is located in a technology hotspot, like say Silicon Valley or Boston, a high churn model may be effortlessly reasonable. But if the R&D laboratories are more geographically isolated, then it is better to have first approach, that is, some degree of job security to attract talent. Portfolio, that is allocation. It refers to the desired resource allocation across different R&D projects and the criteria used in prioritize and select projects. The R&D portfolio should reflect the priorities of the R&D strategy. For example, a pharmaceutical company that intends to win by discovering its own first-in-class drugs should have a different portfolio allocation than a company which is trying to win by developing follow-on drugs in already established drug classes. Final evaluation selection. In evaluating on R&D strategy, it is essential to ask a few basic questions. First, have we been completely clear about how we aim to win? Everyone should appreciate what the meaning are and what they mean for them. Second, the choices that we are making about structure, processes, people, and portfolio are coherent. Are there any major conflicts between our policies? Third, do all our choices form an integrated system focused on the key priorities, how we intend to win? Finally, we need to evaluate our R&D strategy against performance data and recognize when the time has come to reject our initial hypothesis and change strategies. Allocating resource and development resources. There are two alternative options available to the production house firm for the allocation of the research and development resources. The amount of financial commitment in R&D can be based on the following guidelines. Maximum range 5 to 20% of gross profit depending on the industry to minimum range competitors' action. However, these figures provide a potentially wide range of discretion which managers must subjectively determine how the R&D activity fits as a component of overall activity. Application example, the case of pharmaceuticals. Now, with the help of some examples, we are explaining the application of R&D strategies, how companies adopting R&D strategies in their firms for their profitability and growth. Facing increasing competition, more challenging and price sensitive customers, patent ants, and higher controlling burdens, pharmaceutical companies have been in search of new R&D strategies to increase R&D productivity. Because of the high levels of uncertainty in pharmaceutical R&D, attrition rates and the timing of attrition dominate the effect of direct project costs In pharmaceutical R&D productivity, management of these projects effectively and efficiently is certainly important. Better selection of projects and better decisions about which projects to advance have a much bigger impact on overall R&D costs. This is due to the fact that development costs escalate as projects progress. It is no wonder then that most efforts to advance R&D productivity have attentive on the attrition problem. There are many potential policies for dealing with the attrition problem. The purpose of the examples below is not to highlight effective models for improving attrition management. GlaxoSmithKline breaking R&D up into smaller units. In January 2000, after the merger of Glaxo and SmithKline, Besham, the newly formed GlaxoSmithKline (GSK) restructured R&D around organizational focused therapeutic area units, cancer, neurology, etc. These were initially called Centers of Excellence in Drug Discovery (CEDD). Each CEDD was responsible for the development of molecules in its designated therapeutic realm for discovery through proof of concept. GSK continued to centralize early discovery, target identification, and molecule discovery and late-stage development, phase 3 clinical trials, registration, etc. Each CEDD had its own leader and management learned and processed most of the functions required to move a molecule from discovery to proof of concept. Novartis betting on science. In the early 2002, Novartis embarked on a major change in its R&D strategy. It opened a research laboratory in Cambridge, Massachusetts. This was not an unusual move. Other large pharmaceutical companies, including Merck and Pfizer, had opened research laboratories in the Cambridge area to be close to a thriving ecosystem of biotechnology companies and leading academic institutes. What was unusual is that the Swiss-based company decided to move its research headquarters from its home in Basel to Cambridge. This move was part of a broader strategy to make drug discovery at Novartis based on deep scientific understanding of underlying pathways and mechanisms of action. Being geographically close to biotechnology companies and institutions like the Broad, Harvard University, MIT, and the academic medical centers like Massachusetts General Hospital was viewed as essential to accessing and absorbing the relevant science. At the same time, the company recruited heavily from the Boston area's academic science community. For instance, it hired Mark Fishman, a professor at Harvard Medical School and Mass General Hospital, to head research. It hired over 1,000 scientists to staff its Cambridge research laboratories. Value Addition 1. R&D activities of Hindustan Liver. Hindustan Liver Limited (HLL) has its own R&D center known as Hind Liver Research Center (HLRC). HLRC undertakes R&D activities for developing innovative products and processes to make them more valuable. This center has research linkages with various research institutions like Center Leather Research Institute, Chennai, Indian Institute of Science, Bangalore, Center for Cellular and Molecular Biology, Hyderabad, All India Institute of Medical Sciences, New Delhi, etc. HLL has also established Hindustan Liver Research Foundation, HLRF, which provides funds to various institutions for their projects. In the United States, government managers distribute more than $40 billion in research and development (R&D) funds each year. Each of the chief funding agencies, including the National Institute of Health, the Advanced Research Projects Administration, the Office of Naval Research, the National Science Foundation, and the Office of Science in the Department of Energy (DOE), has established its own techniques and customs for the planning, selection, and evaluation of research. In some agencies, government program managers exercise a good deal of autonomy in the selection of projects to fund. In other agencies, program managers have limited discretion and implement judgments made by peer review panels or boards of advance. Similarly, the funding agencies differ a great deal to the average amount of funding, the composition of funding recipients, the longevity of funded projects, and preferred reporting mechanisms. Arguably, the great diversity of government funding programs is a singular strength of the US national innovation systems. Agencies that are line offices in the departments, such as the Department of Defense, must be attuned to the priorities of officials in the department hierarchy. These officials must in turn be constantly vigilant in responding to dictates of political supervisors in Congress and the White House, and to political control executive agencies such as the Office of Management and Budget. Thus, government R&D managers are highly constrained. They seek to allocate R&D funds as effectively as possible, but have no clear-cut criteria by which to demonstrate effectiveness. What is lacking in effectiveness criteria is made up in completing demands. Allocation decisions sometimes need to take into account the diverse, often competing priorities of bureaucratic superiors, federal budget controllers, political institutions, and researcher stakeholder groups who invariably have strong views about why their own research field is particularly deserving of increased resources. It is no wonder that strategic is not often a term taken together with government R&D management. Contrasting government R&D portfolio approaches. They examine two distinct portfolio types. Number one, output maximization portfolio. Two, a balanced portfolio that considers both discrete outputs and scientific and technical human capital. Each of those is described below. Output maximization portfolio. In many instances, government R&D managers seek to maximize the output or impact of one or a few categories of scientific and technical knowledge. For example, several funding units in the National Science Foundation and the National Institute of Health seek to support research that advances fundamental scientific knowledge without any consideration, at least in the short term, as to the application that may flow from that knowledge. Even if there is some general expectation that the knowledge will ultimately lead to application, if the application is essentially a black box, then maximizing fundamental research is not about application. The majority of private sector R&D portfolio managers focus on applied research or development and seek to integrate and make efficient their applied research investments balanced portfolio. Many public managers are as concerned about building up scientific and technical capacity as they are about producing discrete impacts from particular projects. Some public managers, including those at BES, speak eloquently of their roles in nurturing science. This approach leads to different assumptions about program management and to a different portfolio approach. If one seeks to develop an R&D portfolio based on capacity building, then the production function is improvement in scientific and technical human capital. Scientific and technical S&T human capital includes not only the formal educational endowments usually encompassed in traditional human capital concepts, but also the skills, know-how, tactic knowledge and experimental knowledge embodied in individual scientists. S&T human capital is the sum total of scientific, technical and social knowledge and skills embodied in a particular individual. It is the unique set of resources that the individual brings to his or her work and to collaborative efforts. As the production of scientific knowledge is by definition social, many of the skills are more social or political than cognitive. Thus, knowledge of how to manage a team of junior researchers, postdoctors and graduate students is part of S&T human capital. Knowledge of the expertise of other scientists and their degree of willingness to share it is part of S&T human capital. So, the case study described above, based on the assumption and show how resources are brought together to increase capacity. The empirical analysis presented above focuses on how the United States developed its own procedures and norms for the planning, selection, and evaluation of research. Let us summarize. We can say that R&D strategy is a systematic approach which tells how new product being developed and existing improved. In this chapter, we outlined a way to develop a systematic approach to addressing the problems such as how can we make our R&D organization more competitive and effective for the long-term growth and survival. It involves consistent and coherent choices across structure, processes, people and portfolio which actually give us the answers of where, who, how and allocation. And with the help of pharmaceutical examples above, we are able to understand how and why different companies pursued different strategies to essentially address the same problem. The differences were largely rooted in the different core hypotheses, bets on the underlying root cause of the problem. This suggests that the first question to be answered in R&D strategy development is, what is our shared understanding of the root cause of the problem we are trying to solve? And it is also clear from the above chapter that what are all about R&D strategies, their different elements and allocation of R&D strategies. And it is also clear that in the present competitive environment, no firm or industry can survive and compete with its outdated technology, and for that reason being, R&D strategies are very important from the perspective of firms, industries, profitability, growth and survival